We've explored black holes, those terrifying cosmic monsters that swallow light, time, and information. But what if the universe contains their mirror opposites? What if, instead of consuming everything, there are objects that only expel matter? These hypothetical entities are known as white holes. And if they exist, they could solve some of the biggest puzzles in astrophysics, or even connect us to parallel universes. Let's dive into one of the most mysterious, least understood, and potentially most important ideas in modern physics: the white hole. What is a white hole? In essence, a white hole is the time reverse of a black hole. Where a black hole pulls matter in and never lets it escape, a white hole ejects matter, but nothing can ever enter it. Imagine a region of space-time where particles and energy come flying out, but where no object, not even light, can cross the boundary inward. It's like a cosmic fountain, spitting material into space, but completely sealed off from incoming matter. It sounds exotic, but mathematically, white holes naturally arise from the equations of general relativity, the same way black holes do. Einstein's field equations don't forbid them. In fact, the original solution to the Schwarzschild metric, the solution that describes a non-rotating black hole, also includes a white hole. But while we've observed dozens of black holes, we've never seen a white hole. So, why not? Why haven't we found one? There are a few reasons why white holes remain elusive. Instability. White holes are thought to be inherently unstable. Any small disturbance, a photon, a bit of dust, could disrupt the conditions needed for a white hole to remain open, possibly causing it to collapse into a black hole or disappear. Short lifespans. If white holes exist, they might last only a tiny fraction of a second, especially in the early universe. That makes them extremely difficult to detect. Rarity. White holes may only occur under extraordinary conditions, such as the end stages of black hole evaporation or in regions of quantum gravity. But the idea hasn't gone away. In fact, it's gaining traction in new and exciting ways. White holes and black holes, two sides of the same coin? Some physicists propose that black holes and white holes may not be separate objects, but connected. According to this theory, a black hole doesn't end in a singularity, but bounces back due to quantum effects, releasing its contents in the form of a white hole. In this model, black holes don't destroy information. They store and later release it, solving the infamous black hole information paradox. This idea is part of a larger framework called loop quantum gravity, an attempt to unify quantum mechanics and general relativity. One proposal by physicist Carlo Rovelli suggests that after a long period, perhaps even longer than the current age of the universe, a black hole could transition into a white hole, spewing out the information it absorbed over time. This would preserve the laws of quantum physics and potentially reveal what lies beyond the event horizon. Could the Big Bang have been a white hole? Here's where things get really interesting. Some scientists believe the entire universe may have emerged from a white hole. In this view, the Big Bang wasn't the beginning of everything from nothing, but rather the explosive emergence of matter from a white hole formed in a parent universe. Essentially, the death of a black hole in one universe becomes the birth of a new one, through a white hole. It's a variation on the cosmic bounce theory, linking black hole collapse to universal creation. If true, it would mean our universe is part of a cosmic family tree, branching endlessly across dimensions and time. White holes and wormholes. White holes also appear in certain wormhole solutions. A wormhole, or Einstein-Rosen bridge, connects two regions of space-time. In this configuration, one mouth of the wormhole is a black hole, the entrance, and the other is a white hole, the exit. This concept inspired decades of science fiction, from Interstellar to Stargate, and raises tantalizing possibilities. Could white holes allow travel between galaxies? Could they provide safe passage through time? Could they serve as cosmic escape routes? Unfortunately, traversable wormholes require exotic matter with negative energy density, which we haven't yet discovered. But some quantum gravity theories suggest that Planck-scale wormholes may exist, hidden in the foam of space-time. If so, white holes could be embedded throughout the quantum structure of the universe, waiting to be unlocked. Could we detect a white hole? Though no white hole has ever been confirmed, researchers have proposed ways they might reveal themselves. Explosive gamma-ray bursts. Some sudden, short-lived gamma-ray bursts could be caused by microscopic white holes briefly ejecting matter and energy. Unusual gravitational signatures. White holes would affect surrounding space-time, possibly mimicking black holes, but with key differences in motion, light behavior, and radiation. Primordial remnants. White holes may be relics from the early universe, now faded but detectable through patterns in cosmic background radiation or dark matter halos. If any of these signals are found, it would change everything, proving that time-reversed structures exist and that the universe is far stranger than we imagined. Final thought. White holes may remain purely theoretical, for now, but their existence is not forbidden by the laws of physics. They offer a mirror to our understanding of space, time, gravity, and information. And perhaps they hold the key to reconciling quantum mechanics with general relativity. They could be ancient echoes from before time began, or they could be waiting at the end of black holes, holding secrets of other worlds. Here on Infinity Beyond, we believe the universe whispers in opposites, light and dark, matter and antimatter, black holes and white ones, and somewhere in between, the truth awaits.